There is a quadratic function f of x is equal to ax squared plus bx plus c. Find the signs of each values. There is a quadratic function f of x is equal to ax squared plus bx plus c. Find the signs of each values. The value of three signs which were going to be a, b, and c. And we can think about each functions of each values. At first, for the a value, it is a thing that defines the type of the graph, which means when the a is greater than 0, which means when the a value is positive, the graph will go upward. And when the graph goes upward, for example, in this way, the graph will keep going toward up direction, and only point, which we'll call it the vertex, it will going to be the minimum value. And for that minimum value, it only exists when the a value is greater than 0. And for the second case, which a is less than 0, which means when the a value is negative, the graph will go downward. When the graph goes downward, for example, in this way, the only maximum point will exist, and then the graph will go toward downward, which will going to be our maximum point. Our maximum point exists at our quadratic function when the a value is equal to negative. And for the maximum value and the minimum value, if we add those terms together, we call it into a vertex. So vertex can have two cases where it can be minimum or maximum value, depends on the a value. And for the c, right over here, the c, it is a value of the y-intercept. Intercept means when the sum value is equal to 0. When the sum value is equal to 0, another value exists. And if it is y-intercept, that means when the x value is equal to 0, the y value exists, but we can just notate it as y value because we don't know exact value of it. The reason why the c value is y-intercept, which means it will going to be the y value when the x value is equal to 0, it is because there is two terms which contains a variables. In this case, we're going to be the x value. If we input the value of 0 to our every terms, if we can write our function down, which will going to be f of x is equal to ax squared plus bx plus c. But if we input 0 to our x value, it will going to be a times 0 squared plus 0x times x plus c. These terms we're going to cancel out as 0, which we're just going to have our answer fc. So that's why c represents or stands for the y-intercept. There are three questions that we need to solve. The first one is a plus b plus c, and then 9a plus 9 is 3b plus c, and then lastly a plus 2b plus 4c. And we're trying to find the values of signs, not exact values of each addition. Let's do for a plus b plus c first. So we can see that for our x-intercept, which we're going to just call it p, should be always greater than 3. And let's get to our question, a plus b plus c. So if you write that down, a plus b plus c, it is f of x is equal to a plus b plus c. If you see here, our x values are all gone, which means we inputted some values as our x values. But if you think about it from our original function, which is f of x, is equal to ax squared plus bx plus c. And our x values didn't really affect our c, which is a constant. It only affected our x terms, which it removed all of them, which means it can't be 0, because if it's turned to 0, this term will going to cancel out. the x term should be equal to 1. So they inputted 1 as our input of our function. So this function will going to be f of 1. And then we can find f of 1, which the x value is equal to 1, from our function visually and prove that where that located. And we can actually see through our intersecting point where the f1 is greater than 0 or less than 0. Instead of solving for the a plus b plus c, let's find the another x-intercept first. But for the x-intercept, it is the same concept with the y-intercept, which means when the x value exists, the y value should always be equal to 0. So 0 will going to be our y value. And this is what x-intercept means. So for the x-intercept, in this case, there's -3, and there is another one right over here. We cannot find the exact value of it because they didn't give us the value of a and b as well as c. So we can only solve for the area or the or we can just find the how large that is. And for there, it is another x-intercept. As a step of solving for this x-intercept area, we can use one more point that for here, it will going to be the minimum point of our graph, which we'll also call it as vertex, which means as we apply our a concept to this question, this a value, which is the leading coefficient, should be greater than 0 because the graph is going upward and only the minimum point exists. But we know that for every vertex or every coordinates, if we convert this into the normal coordinates, it is formed by x comma y, which we don't know. We can just kind of convert this as a unknown quantity or unknown variables. And for the x value, we know that every is an average of 2 x-intercept. This is part of our quadratic functions property that for the vertex, which we're gonna consider as x comma y, the x value should always be average of 2 x-intercept, which means for this term it should be exact middle of this 2 x-intercept, and we can solve for this area of this another unknown quantity of x-intercept using this property of quadratic function. But if you look at x value should be greater than 0, which means the x value should be positive in this case. The reason is because the 0 is right over here, which we call the origin, but the x value is clearly over 0, which means the x value should be positive. And it is an average. The average is x, another word, we can say a plus b divided by 2, which is essentially finding the median of two numbers. A is a first number, b is a second number. So if you apply it, it will going to be a will going to be the first number, the order is not matter, -3 plus b, we'll just call it as p because we don't know exact value of it, and if you divide it by 2. Let's think about some points that we can input as our another x-intercept. But if we input the value of p value as some number, let's just say as 3, let's say 2. If we input the value of 2, we're going to be -3 plus 2 divided by 2, which will going to be -1. It is clearly less than 0. And our property is this one, our x value vertex, which should be the median of 2 x-intercept, should be greater than 0. Which means even though we input the value of p as 3, it will still going to be 0. So we've kind of figured out the p value, which is our x-intercept. that p-value should always be greater than 3, which means it should be at least 4. So we can see that for our x-intercept, which we're going to just call it p, should be always greater than 3. And let's get to our question, a plus b plus c. So if you write that down, a plus b plus c, it is f of x is equal to a plus b plus c. If you see here, our x values are all gone, which means we inputted some values as our x values. But if you think about it from our original function, which is f of x, is equal to ax squared plus bx plus c. And our x values didn't really affect our c, which is a constant. It only affected our x terms, which it removed all of them, which means it can't be 0, because if it's turned to 0, this term will going to cancel out. The x term should be equal to 1. So they inputted 1 as our input of our function. So this function will going to be f of 1. And then we can find f of 1, which the x value is equal to 1, from our function visually and prove that where that located. And we can actually see through our intersecting point where the f1 is greater than 0 or less than 0. We have known that for the coordinates it is made of x comma y, and this x comma y should be the point that satisfies our original function. So if you see the input of our function, which was going to be 1, then we're going to be the output of our function as our y value. The y is our output of our function. And we can see our value. So the 1 should obviously going to be greater than 0, which means we can just approximately locate 1 here, because the 3 is right over the greater than 3, p, which is greater than 3, is located here. So if you follow the x into up direction, there is nothing that intersects with that point, which means if we go downward, it intersects with a point, which is the output of our function, but our y value is a negative value there. So we can see that if we input the value of x as 1, the y value will going to be as our output less than 0. So we can see that our f1 is clearly less than 0. So our first one, which was a plus b plus c, it is less than 0 according to our visual proof. Next one is also the same, 90 minus 3b plus c. If you see the input, this is obviously going to be f of x, is same thing with y. So if you find the input of our function, which affected our function right over here, if you see it through, if you pick the point and see where it intersects with our y value, we're going to get an output, and we're going to be find the values of size of each values, which is our strategy, and it's also going to be the ultimate goal of this question. Let's write our original function down, which was f of x is equal to ax squared plus bx plus c. And our change function was 9a minus 3b plus c. Again, we can see that there is no effect to our constant of c, which means they only affected our x inputs. So we need to find the values of x inputs, which change into in this way. So at first, what we see here is we can, let's just check for the bx first, because it is a first power term, which means it is not to confuse more than 9x squared term, which it contains squared. So from the bx to the negative 3b, b are same value. Only thing that are different is negative 3. So we can clearly see that our value of x value in this case will going to be negative 3. And we can also prove it right over here. So 9x squared to the 9a. So let's input the value of -3 as the original value. It will going to be a times -3 squared. Even though we input the value of negative, there's a square term, which means it will going to be -3 squared will going to be 9. We have a, which satisfies our inputs and outputs of our function. So we can see that this function will going to be f of -3, where we input x value as -3 as our function. So if we visually prove the -3, so our x value is -3, from our graph we'll be able to find whether it is greater than 0, less than 0, or equal to 0. The x value is -3, it is right over here, but we have said that -3 is the x-intercept, which means, so it is the x-intercept, which means the x-intercept means the x value exists and the y value is equal to 0, but this case x value is -3. So we can see that it is not greater than 0, it is not less than 0, it is exactly the same thing with 0. And we need to remember that f of x is equal to y, which is our output of our function. Our y value when the x value is -3 equal to 0. So we can say that our y value is exactly the same thing with 0. So let's do the next one, which a plus 2b plus 4c. Which we're going to be number 3 is a plus 2b plus 4c. And again, let's find our infinite function. Our original function was f of x is equal to ax squared plus bx plus c. And we need to remember that in order to find the affection, what affects our function, we also always need to find our input of our function, which is x. And that we always need to draw a graph in order to visually prove that if this is right or not. And for the f of x is equal to ax squared plus bx plus c. And here let's think about in this way. For the c, they affected our c, which means, so the input of our function should affect our c. What they did is they multiplied by 4. But here, they didn't multiply by 4, so we can think about another way. If we input the value of x value as 1 over 2, and this is in lack of our calculation problem, if we go f of 1 over 2, that means we need to input every single x values into 1 over 2, which will turn into a. So we're going to be 1 over 4 times a plus 1 over 2b plus c. And then, because the leading coefficient is not equal to 1, it will going to be hard. You're going to be difficult to calculate, which means we can multiply 4 into every single terms. Then it will turn into 4f of 1 over 2. The same thing with 1 over 4 times 4 will turn into just a, 1. Plus 1 over 2 times 4 will going to be 2. We have b, and we still have 4c. So we can again prove that is exactly the same thing. So we need good calculation or to solve this last one, a plus 2b plus 4c. Lastly, they're talking about 4 times f 1 over 2, but we're trying to just find the 4 times f 1 over 2. We're trying to find a plus 2b plus 4c. But we don't have to multiply by 4. We can just leave it as our original function, because even though we multiply every single term into 4, since we have the equal side, they also have to multiply 4, which means if we just divide every single term into 4 again, we're going to get our original function, which will going to be f of 1 over 2, and we're just writing the same thing down, is equal to 1 over 4 a plus 1 over 2b plus c. The reason is because it's hard to calculate if there is a multiple 4 in front of our function. And also, we don't really have to multiply for it. That makes the calculation harder. So f of 1 for the x is our input of our function, which was 1 over q. So we can just write this as same thing with f of 1 over q. And that is equal to 1 over 4a plus 1 over 2b plus c. So we can find the value of 1 over q as our x value, and c where is our output of our function. 1 over q is obviously greater than 0, but it is less than 1, which means it will going to be the median, which will approximately locate right over here. If you go upward, there is no intersection between the x values and the y values, because the function is a x and then y, which always contains output and input. So if you go down from the 1 over 2, so it is 1 over 2 here, it will going to meet as a negative value. It will going to meet as some point right over here. But our output of our function, which we can sum up as y value, is in the negative value. Which means when you input the value of f of 1 over 2, and our x value is 1 over 2, it will going to be less than 0. So we can write as, again, less than 0.